All right. Force diagram, net force equation, all that fun stuff with inclined planes. Yay! Jazz hands. All right, so here's your challenge problem. You've got the Red Hood is escaping someone for some reason. He's sliding down an incline. His mass is 90 kilograms. You want to find the normal force and the force of friction acting on him. Go. All right, that's your challenge. All right, so I'm going to pause the video, work on it, and I'll come back and I'll reveal step by step what I did. All right, so pause. All right, well, if you're still with me, I'm going to assume that you want to know what the answers are. So let's check out what the answers are. Answer for that one, force of friction, is 301. Yay! And the answer for the normal force is 828. So if you got those, then you're in good shape. You're good to go. And you need no more guidance from me. If you did not get these, then we should probably talk about that. All right? So first clue. Did you realize that gravity was going to be at a bit of an incline? And draw your force diagram that way. So there you go. That was my rough sketch of the situation. And you realize, oh my gosh, I got to bust up the force of gravity. So if you didn't do that, please do that now. Give it a shot. See if that alludes you to those following answers. If not, I'll come back with a much better force diagram to help guide you further. So pause the video, give it a shot, or you can continue watching, trying to figure out, hey, what should the actual force diagram look like? Well, here it is. Here's the force diagram. This is what I finally did. Gone. All right. So when I redid it, I changed my axes. I started saying, hey, y is perpendicular to the surface, x is parallel to the surface. So I'm going to draw my new force diagram like so. I have an x component to gravity. I have a y component to gravity. And I wrote it out as the force of gravity times cosine of the angle and the force of gravity times sine of the angle. And if you're wondering, hey, where to get that from? Go check out one of the videos where I break down how you figure out how inclined planes actually work. All right. So now once we have this, you should be able to draw some fantastic net force equations for the x-plane and the y-plane. All right, so give that a shot now that this is before you and see if you can take it home to the finish line. If not, I'll reveal those net force equations and hopefully then you'll see where the errors were made in your judgment. All right, so see you in a second. All right, we're back. Check out net force equations. So there you go. There's the x equation. And there's the y equation. So here you can see how we broke it up into its components, x and y. Force of gravity was represented in each case. Here the force of gravity is positive, so let's make him slide down the ramp in a positive direction. Friction's negative, going against him. So the only thing you don't know is the force of friction, so solve. Here in the y-plane, the force of gravity was negative because it pulls him down, and the normal force is positive because it pushes up perpendicular to the surface. And therefore we wrote it all out. The only thing we don't know is the normal force. So solve for that and you're good to go. So key things, remember, you got to flip cosine and sine from your normal convention usually. And you have to remember to break up the force of gravity into its x and y components. So hopefully that was doable for you. If not, we've got more practice problems. Feel free to try them out. Come in and seek some guidance if you need it. But either way, see you in class.